makes that more interesting is that Sagittarius is a very, very difficult constellation to find anything in. It's very, very busy. It's looking into sort of almost the heart of the galaxy, really, and it's a very busy area because you're looking straight into the Milky Way. It's almost like trying to find one tiny little source of light amongst a million light bulbs. So that area it seems commonsensical to me that if we've missed something, if we haven't spotted an object that we should have done, that it would be buried in amongst lots and lots of other objects, which would make it more hidden. One of the ideas to think about with this is the fact that oftentimes, or reasonably often, astronomers have catalogued certain very faint sources of light as being a star at a certain distance or a certain magnitude star. And when they've come to sort of, with better equipment, come and have a look at it again some years later, they've realized that it was misinterpreted and catalogued erroneously. And in the same way as that neutron star that you talked about earlier on, there's also been at least one red dwarf that was thought to be a background star in the Milky Way that turned out to be a very, very small star that was much, much closer to us. And one of the possibilities about the dark star is that it's actually has been discovered and that it is what it's thought to be a background star that sat in a catalogue somewhere, sort of unloved, and it turns out to be this object that's quite dark but very, very close to us. And Sagittarius for me would be an excellent place for that to happen, because for a couple of technical reasons, it's a very, very difficult area to look at, especially in the northern hemisphere. It's not a constellation that lends itself to discovering tiny objects.
So this is...
To back that up on a sort of scientific level, because people might think, oh, he's just making that up. When the chaps and the ladies astronomers who are working to try and find very, very small and new bodies beyond Pluto, where they work, they don't tend to look into the bright constellations. They purposely pick dark constellations, which are bereft of stars, like Pisces, and they point their scanners and their telescopes in those directions because they're more likely to be able to find objects. And it sort of gives you an indication that, if an object is in an unpopular place to research, it's less likely to be discovered. And I think that's probably what's happening here.
That's interesting. So again, this is coming from the center of the galaxy almost then?
Well, it lies in the center of the galaxy. I mean, if you just sort of, your eye, when it looks out into space, it's picking up light that's traveled from a number of different distances. And if you look at the moon, and you look beyond the moon to a planet, and then you look out towards the stars, the light's coming from a number of variable distances. And, if the moon's in Sagittarius, then the light from the moon's coming from the direction of the center of the galaxy, but it's coming from the moon. And this is the same with this object. It lies and doesn't really move very much from where it is. It's just sort of sat there, and its light could be coming effectively from the center of the galaxy, but it's actually reasonably close to us, astronomically speaking. And this is why I think it's in that particular region. It's just surrounded by other light sources of similar nature, and it's simply very, very difficult to pick up as being an object that's close to us. But that's what I think that's going to be found. So when you're looking for brown dwarfs, you don't tend to look in the light at all, the light regions. You tend to look in the infrared. You look for heat sources.
Yeah.
Because their light emissions are very, very dim. And in the instance of this particular thing, it would simply be the light reflected back from our sun, really. But the heat signature of it would be more of a giveaway. But scientists find that very, very difficult to achieve because, obviously, here on Earth, we're surrounded by heat. And even in the coldest regions of the planet, there is still background radiation, there's still background warmth, even though it's you need to get into space. You need to get telescopes into space to even have a decent chance of picking up these very, very sort of small telltale infrared signatures.
Mm-hmm.
And although there are infrared telescopes on the ground, they're not nearly as effective as the ones in space. Now, the last time astronomers looked for infrared signatures was called IRAS back in the mid-1980s.
Mm-hmm.
So it's been over 20 years since we've had a decent sky search for infrared objects. And in a few years' time, we're going to have another one. And I think that one, which is called SIRTF, that'll be the one that picks this object up. Okay,
yeah. I've heard speaking of Planet X and so forth, that the observatory at Mount Graham near Safford in Arizona, this is known as the Vatican Advanced Technology Telescope, and I've heard that they actually search in the infrared spectrum. This might be wrong. I have no idea. Have you heard about this?
I wasn't aware that they'd search in infrared. I think that would be extremely difficult given that they're in the middle of Arizona.
Yeah.
The infrared scopes that I'm aware of tend to be sat on the top of very cold mountains or are at the poles. And there's been quite a lot of talk recently about a telescope, infrared telescope down in the Antarctic, for instance.
Yeah.
And you really need to put them in particularly cold areas because you need to. Otherwise, your infrared search is just ruined by all the background heat.
Pick up the heat. Okay. Yeah.
Exactly. So, in the same way, for instance, that I'm going slightly off the tangent, but it gives you sort of a general feel of it from another instance.
Mm-hmm.
When the SETI astronomers are trying to pick up signals of extraterrestrial life using their scopes, every so often they'll pick up a signal that will move across their scopes, and then they'll know that that's due to a satellite. There are man-made conditions out there that you have to eliminate in your search, and there are also background radiation and background heat signatures from the planet. So the only real chance you've got of doing a decent infrared search is to get something up in space, and quite why it's taken them 23 years to put another infrared scope up into space is quite beyond me, really, because the IRAS search was not complete. And not only was it not complete, but they sort of never really finished up looking at all of the details of the findings that they did get. They ran out of money before the project could have been finished, and it was all sewn up before all the data was properly analysed. It's not uncommon, but a lot of people talk about IRAS as being, if there was a Planet X out there, IRAS would have picked it up. And they're somewhat unaware, or they give too much credence to the idea that IRAS wasn't perfect. Now, the new scope that's going up, that's going to be, I don't know how many magnitude times more powerful than IRAS was, but it's certainly going to be a lot better. I think it's about 1,000 times better than IRAS. So, as long as they do the job properly with the thing, then it should pick up objects like planets orbiting the sun that we haven't spotted yet. It's quite an exciting possibility.
Wow. And did you say, when is this going up again?
I'm not entirely certain, to be honest. I'm not sure where the launch date is, but it's in the next 2 or 3 years. It's sort of in the building stage, I think.
Okay.
But these projects tend to take quite a long time. They get planned, they get built, and then they get launched, and then they take a year to calibrate and collect the data, and then the data comes back, and that takes another year to,
That's right.
Even after the launch of the thing, it's going to be some years before there's sort of useful data from it. So it's going to be a little while, but the point I sort of make with this is that from a scientific point of view, my case is provable, and it's also disprovable, and a lot of alternative knowledge is almost built around a hypothesis that you can neither prove nor disprove, but this one you can. In the next few years, if that scope and another one called WISE don't pick this object up, then either you've got a massive conspiracy theory going on, or it's simply not there. And it will just put the whole subject to bed. But personally, from my point of view, I think quite interesting discoveries, and I think that they'll find a few things that they weren't expecting.
Fascinating, and that's kind of the most I think we can get out of the science bit for now, and if we kind of move towards the mythology bit a little bit here, and just one thing that I want to run by, of course, before we do that is, you say that this object, potentially then is has heat and light coming out from it. Potentially could even be planets around it. An obvious question here is then, could these planets be habitated,
Yeah, absolutely. The potential for life around this thing is very high. Around Jupiter, there are 4 major moons, the Galilean moons, which were discovered by Galileo way back when. And in fact, his discovery of those moons was the thing that sort of put bed to the idea that the sun went round the Earth. So it's a very important discovery, and potentially even more important than that is the possibility that those moons have life on them.
Mm-hmm.
At least one, possibly 3 of them are oceanic. They've got large oceans of water sat underneath large ice sheets, and they're like sort of almost like billiard balls. Mm-hmm. They're super round. They've got these massive thick ice sheets, but underneath the ice, the gravity of Jupiter sort of drives tidal currents and warming effects from its fields that create these oceans. And of course, life could well be found underneath them, and there's quite a lot of evidence for that. You'll have to wait until the probe goes up to Europa at some point to find out. But there's a very distinct possibility, a scientific possibility, that life exists around there. Now, if you take the dark star as being a larger than Jupiter world, a heavier than Jupiter world, which is a little bit more active than Jupiter. It's not like the sun, it's not bursting with light, but it's creating a bit of heat. It's a little bit more excitable than Jupiter. And you put moons around it, which are similar to Europa, or possibly even the size of Earth, and you put them at the right distance, then in the same way that Europa is warmed up by Jupiter, those planets would be warmed up by the dark star. And I would contend that you could have the right conditions quite easily where you wouldn't have to just have an ocean underneath a sort of billiard ball type ice sheet, that you could have a surface world like Earth, which is sufficiently warmed to have surface oceans, atmosphere, and so on. And that would create the potential for life to exist on the surface of a world there. So this is my contention. Now, some people argue, well, that's all very well and good, but without sort of a good source of light, how on earth are you going to really get life kick-start? You need light to produce the energy. And of course, now we know that that's not necessarily the case, that life can exist under very extreme conditions. And also we are aware that photosynthesis can occur in quite dim, dark areas underneath oceans and so on. So there is great potential for life to exist out there, almost to sort of the comet fields, if this dark star idea is workable. And that leads on to other sort of more, how do we put it, less scientific ideas and more speculative ideas to do with the existence of aliens.
Yes, indeed. Exactly, and that's a fascinating area, and let's indeed go there and explore that, because that's what this is all about here. And speaking of the mythology here, going back to how things were on this planet before, there are a lot of references in different mythologies from around the world of other planets